Very important point to note here is that this shortcut is extremely easy, extremely time efficient. You can use this shortcut in school, you'll get marks. You can use this shortcut in JEE and NEET to calculate your answer very quickly. So as you can see, in just 3 to 4 lines, you are able to solve the whole redox equation question if you understand these steps thoroughly. Hello everyone, welcome to ATP STEM education. I am Apurv and today we will learn how to balance a redox equation really quickly in just 4 steps. Now this shortcut can be used for your school exams. It can also be used in your JEE and NEET exam to calculate the answer quickly, and for your school exams you can use this shortcut to check your answers. So let's quickly go through the steps of this shortcut and then we'll go through an example to understand each and every aspect of this shortcut. Let's begin. The first step is to calculate the change in oxidation number in both half reactions and make the change equal. The second step is to balance those atoms whose oxidation state is changing. The third step is to balance charge. Now this step depends upon the medium. If the medium is acidic, we will use H plus to balance the charge, and if the medium is basic, we will use OH minus to balance the charge. The fourth and the final step is to balance hydrogen atoms and oxygen atoms by adding water on the appropriate sides. So I would recommend all of you to quickly pause this video, take a screenshot of these 4 steps, and then let's move ahead and try to solve a question using these 4 steps. So let's try to solve this question using the steps which I just told you. So in this question, first of all, we are supposed to calculate the change in oxidation state and make the change equal in both half reactions. So the oxidation state of manganese here is +7 and the oxidation state of manganese here is +4. What is the change in oxidation state of manganese? So from +7 it's going to +4, so the change is of 7 minus 4, so that is +3. So the change in oxidation state of manganese is +3. Whereas oxidation state of iodine here is -1 and here is 0. So what is the change in oxidation state of iodine? The change in oxidation state of iodine is 1. So we have to make the change equal in both half reactions. We can do that by multiplying this iodine with 3 so that the change in oxidation number in both half reactions becomes equal to 3. So we are done with the first step, which was to calculate the change in oxidation number and make the change equal by multiplying with a suitable number. The second step is to balance those atoms whose oxidation state is changing. So oxidation state of manganese and iodine is changing. So we need to balance these 2 atoms. Let's write down manganese and iodine so that we remember, and now let's balance manganese and iodine atoms. Fortunately, manganese is already balanced as there is 1 manganese atom on the reactant side and 1 manganese atom on the product side. So manganese is already balanced. Let's try to balance iodine. Now unfortunately iodine is not balanced. There are 3 iodine atoms on the reactant side, but on the product side there are 2 iodine atoms. So we can multiply this 2 with 3 by 2 because as all of us would know that 3 by 2 into 2 is equal to 3. So with this we are done with the second step also. We have balanced those atoms whose oxidation state is changing. Now let's move on to the third step. The third step depends upon the medium. If the medium is acidic, we will balance charge using H plus, and if the medium is basic, we will balance charge using OH minus. But before doing that, let's calculate the net charge on both half reactions. So I'll very quickly rewrite this equation. So the equation is MnO4 minus plus 3I minus gives MnO2 plus 3 by 2 I2. On the product side, MnO2 is a neutral molecule, so it has a charge of 0. Iodine is a neutral molecule, so it also has a charge of 0. So the net charge on product side is 0, whereas the net charge on the reactant side, MnO4 has a charge of -1, iodine also has a charge of -1, but there are 3 iodine atoms. So I'll multiply -1 with 3. So the net charge on reactant side, is -4, whereas the net charge on the product side is 0. So we have to balance the charge. That is the third step. We have to make the net charge equal in both half reactions. How will we do that? That depends upon the medium. If it is acidic medium, we will balance the charge using H+. Let's do that. So if the medium was acidic, I would have balanced charge using H+. So as we know, on the reactant side, the net charge is -4, and on the product side, the net charge is 0. If I add 4H+ on the reactant side, the net charge on the reactant side will also become equal to 0, because -4 plus 1 into 4, so -4 plus 4 will be equal to 0, because as we know, each H+ carries a charge of +1. So 4H+ will carry a charge of 4 into +1, so that is +4. So if I add 4H+ on the reactant side, the net charge will become equal on both half reactions, and we would be done with the third step for acidic medium. Now let's talk about basic medium. Very important point to note here is that this shortcut is extremely easy, extremely time efficient. You can use this shortcut in school, you will get marks. You can use this shortcut in JEE and NEET to calculate your answer very quickly. So if it is basic medium, we will be using OH- to balance charge. Each OH- has a charge of -1, right? So let me just rewrite the equation. MnO4- plus 3I- gives MnO2 plus 3/2I2. So now in this equation, the net charge on the reactant side is -4, on the product side is 0. If we add 4OH-, the net charge on the product side also becomes equal to -4. 0, that was the existing charge, plus 4 into -1. So the net charge on the product side will also become equal to -4. So with this, we are done with both the mediums, acidic medium as well as basic medium. In the question, they will specify in which medium to balance. Right now, I am solving using both the mediums, but in the exam, you would be doing one of these, either acidic or basic, depending upon the question. With this, we are done with the third step. Let's move on to the fourth step. The fourth step is to balance H atoms and O atoms using water. So we can balance either H atom or O atom, and the other one will automatically get balanced. For example, I will be balancing O atoms and the H atoms will automatically get balanced. Let's see how. So in acidic medium, how many oxygen atoms are there on the reactant side? There are 4 oxygen atoms. You can see that MnO4 is the only reactant which has oxygen atoms, and it has 4 oxygen atoms. Whereas on the product side, how many oxygen atoms are there? On the product side, there are 2 oxygen atoms. So we have to make 2 and 4 equal. We can do that by adding 2 water molecules on the product side, because each water molecule carries 1 oxygen atom. So 2 water molecules will carry 2 oxygen atom. That will make the number of oxygen atom 4 on both sides of the reaction. And with this, hydrogen will get automatically balanced. We can see that from here. The total hydrogen atoms are 4. That is 2 into 2, because 2 and into 2, so that is 4. The total hydrogen atoms are 4 on the product side, whereas on the reactant side also they are 4H+, right? So as you can see, if we balance oxygen, hydrogen is automatically balanced, and this is the final balanced equation in acidic medium. Now let's do the same in the basic medium as well. So in the basic medium, how many oxygen atoms are there on the reactant side? On the reactant side, there are 4 oxygen atoms. Whereas on the product side, how many oxygen atoms are there? 2 oxygen atoms are here and 4 oxygen atoms are in this OH-. So on the product side, there are 6 oxygen atoms. Whereas on the reactant side, there are 4 oxygen atoms. If we add 2 water molecules on the reactant side, number of oxygen atoms will become 6 in both half reactions and hydrogen will automatically get balanced. I'll again show you that there are 4 hydrogen atoms in this whole reactant side, whereas on the product side also there are 4 hydrogen atoms. So this is the balanced equation, this is the net balanced equation for basic medium. So as you can see, in just 3 to 4 lines, you are able to solve the whole redox equation question if you understand these steps thoroughly. Whereas if you follow the traditional half reaction method, it almost fills up a page. So you can imagine how much time this is saving for you in exam and especially in JEE and NEET where time is of vital importance. Let's do one more question in order to understand this method more properly. This time we will be solving only in one medium, that is acidic medium. Basic medium, you can try it on your own, and if you are not able to solve, you can just let me know. I'll attach a PDF of the basic medium in the description of this video. Okay, so this is the question which we will solve next. In this question also, let's very quickly apply the shortcut and get the answer. First step is to calculate the change in oxidation number and make the change equal. Oxidation number of manganese here is +7 and here is +2. So what is the change in oxidation number of manganese? The change in oxidation number of manganese is of 5. Whereas what is the oxidation number of carbon here? The oxidation number of carbon here is +3 and the oxidation number of carbon here is +4. So what is the change in oxidation number? The change in oxidation number of carbon is 1, but there are 2 carbon atoms already on the reactant side. So we will have to multiply the change in oxidation number with that to get the net change in oxidation number, which is 2. So the net change in oxidation number for carbon is 2 and for manganese is 5. We have to make both of them equal. We can do that by multiplying this with 2. So we will get the change in oxidation number of 10 here and multiplying this with 5 so that we get the change in oxidation number of 10 here once again. So with this we are done with the first step. Let's move on to the second step. In the second step we balance those atoms whose oxidation state is changing. So oxidation state of manganese is changing, oxidation state of carbon is changing, so we need to balance these atoms. So there are 2 manganese atoms on the reactant side, so let's make the manganese atoms on the product side also equal to 2 by adding 2 there. Similarly, there are 10 carbon atoms on the reactant side. So let's make the carbon atoms on the product side also 10 by multiplying it with 10. With this, we are done with the second step. Let's move on to the third step. In the third step, we balance charge, and this time we will do the third step just for acidic medium. So very quickly, let me rewrite this equation. So we have 2MnO4 minus plus 5C2O4 2 minus gives 2Mn2 plus 10 CO2. So what is the net charge on this equation on the product side? On the product side, the net charge is, see, manganese has a charge of +2 and there are 2 manganese atoms, so the net charge on the product side is +4. Whereas on the reactant side, what is the net charge? On the reactant side, the net charge is 2 into -1 plus 5 into -2. So the net charge on the reactant side is -12. So we have to make -12 and +4 equal. We can do that by adding H+. So if we add 16H+ on the reactant side, the net charge on the reactant side will also become equal to +4, and in this way we will be able to balance the charge. We are doing this step for acidic medium. For basic medium, you can try it out on your own. With this, we are done with the third step. Let's move on to the fourth and the final step, that is to balance hydrogen atoms and oxygen atoms using water. So let me very quickly rewrite this equation and then we will balance hydrogen and oxygen atoms. So the equation is 16H plus 2MnO4 minus plus 5C2O4 2 minus, that gives us 2Mn2 plus 10 CO2. How many oxygen atoms are there on the product side? So oxygen atoms here are 10 into 2, so that is 20. And how many oxygen atoms are there on the reactant side? So on the reactant side, we have 2 into 4 number of oxygen atoms in this equation, number of oxygen atoms in this reactant, plus 5 into 4. So that is 28. So on the reactant side, we have 28 oxygen atoms. On the product side, we have 20 oxygen atoms. We have to make this equal. We can do that by adding 8 water molecules on the product side, because each water molecule contains 1 oxygen atom. So 8 water molecules will contain 8 oxygen atoms. So due to that, number of oxygen atoms on the product side also will become equal to 28. With this, hydrogen atoms will automatically get balanced. You can see that there are 16 hydrogen atoms here and there are 16 hydrogen atoms here also. So hydrogen atoms automatically get balanced. With this, we are done with the shortcut technique, and I hope you understood everything that we did today. If you have any kinds of doubt, please feel free to drop me a comment. I'll get back to you. And if you like this content, please like and subscribe, and I'll see you around in next video. Bye bye guys. Thank you.